This video contains the solutions to the limits and continuity practice problems. For these first few problems, we're finding limits to the origin along several different paths and then trying to draw conclusions as to the meaning of our results. So for the first bullet point, we're asked for the limit as xy goes to 0, 0 along the x-axis. So what we have to remember here is that when we say along the x-axis, remember that means that when y is equal to 0. So we're going to be looking at the limit as xy goes to 0, 0 of x over x minus y. But if we say y equals 0, that means that we're really just looking at the limit as x goes to 0, because y is already at 0. So as x goes to 0, of what we get when we plug in y equals 0. In other words, that's x over x minus 0. That's the limit as x goes to 0 of x over x, which is just 1, and that's going to work out to be 1. Now for the second bullet point, we need to find, we're still on the first bullet point, and we also want to do the y-axis. So the y-axis is where x equals 0. So again, we're looking at the limit as xy goes to 0, 0 of x over x minus y. But now we're looking at x equaling 0. So that means we're really just looking at the limit as y goes to 0. X is already at 0. So the limit as x goes to 0. The limit as y goes to 0. And x is already at 0. So we get 0 over 0 minus y. That's the limit of 0, which means we just get 0. Now we can already tell, since we've gotten two different results, that the overall limit as xy goes to 0, 0 of this function does not exist, because we got two different results along two different paths. But just as practice, let's pick a different path to the origin and use that as our for our limit. Now, there are a lot of different lines that we could choose, basically any line that we can think of that goes through the origin. A simple line we might think of as y equals x, but quickly observing our function, if we let y equal x, our denominator is going to be undefined. So we don't want to use that one. So let's instead use, how about y equals 2x, the line through the origin that has slope 2. So again, we're looking at the limit as xy goes to 0, 0 of x over x minus y. So if we let y equal 2x, there aren't going to be any y's anymore, so we're just looking at the limit as x goes to 0 of x over x minus 2x. That's just going to be negative 1, because we have x on the top and minus x on the bottom, and so that limit will be negative 1. So in fact, we got a third different result as the xy approached 0, 0. So definitely this limit does not exist. Okay, so again, very similar to the one that we just did. Again, we'll start with the x-axis. Remember, the x-axis is where y equals 0. That means that we're going to be looking at the limit as x goes to 0 of what we get when we replace y by 0. So that'll be x squared minus 0 squared divided by x minus 0. So that would be the limit as x goes to 0 of just x, and that's going to be 0. And if we look at the y-axis, where x equals 0, that'll be the limit as x goes to 0 of 0 squared minus y squared divided by 0 minus y. Sorry, this is the limit as y goes to 0. So that's going to be y squared over y, which is just y. And then again, as y goes to 0, that's going to be 0. So far it's looking good for this limit existing, but let's try another path through the origin. Again, a simple path that we might want to try would be y equals x, but once again, this function is not defined along that line. So let's pick a different one. Let's do the same thing we did last time, which is to pick y equals 2x. So again, there won't be any y's anymore, so we'll just be looking at the limit as x goes to 0 of, now y has been replaced by 2x, so this is x squared minus, parentheses, 2x squared divided by x minus 2x. So on the top, we're going to get negative 3x squared, and on the bottom, we're going to get negative x, so this is just a positive 3x, but then as x goes to 0, we once again get 0. And so we might wonder whether we have enough information to determine that the limit as xy goes to 0, 0 of this function actually equals 0. All of the limits that we got, all of the different paths that we tried gave us 0. So is that enough information to conclude that the limit equals 0? And the answer to that question is no. It's not enough to just try a bunch of different paths and get the same answer over and over and over again. We would have to somehow convince ourselves that no matter what path we chose to the origin, that this limit is going to equal 0. And we can do that for this function. The question that we're answering, we're done answering this question. The answer of whether we have enough information is no. But it turns out that this limit really does equal 0, and here's how we would prove it. we would do some algebraic simplification. We would factor the top of our fraction. We realize that x squared minus y squared is x minus y times x plus y. We can divide out the x minus y's. That gives us the limit as xy goes to 0, 0 of the function x plus y. That function is continuous, which means we can just plug into it, and we get that the limit really does equal 0. But these three results are not enough to conclude that that's 0. It's this argument over here, that's what's necessary to conclude that the limit actually equals 0. All right, one more example, again, very similar to what we've been doing. If we're talking about the x-axis, that's where y equals 0. And that's going to give us the limit as x goes to 0 of x times 0 divided by x squared plus 0 squared. That's just 0. And so the limit of 0 is 0. Similarly, the y-axis, that's where x equals 0. That's giving me the limit as y goes to 0 of 0 times y divided by 0 squared plus y squared. That's also just the limit of 0. And that's going to be 0. So again, it's looking like this one's going to be 0, but let's see what happens when we pick a different path. This time we can use the line y equals x, because my function is defined along that line. So we'll use that, y equals x. This gives us the limit as x goes to 0. Y is about to get replaced by x, so we get x times x divided by x squared plus x squared. That's going to give us x squared on the top and 2x squared on the bottom, which gives us 1/2. And as x goes to 0, 1/2 doesn't care about x going to 0 because it doesn't have any x's in it, and so we get 1/2. So the question of whether we have enough information, do we have enough information? The answer is yes, we do have enough information. This limit does not exist. So the only thing that checking different paths is going to tell you is it's either going to tell you nothing, because all of the different paths you try give you the same answer, and you'll have to think of some other way to evaluate the limit, or it's going to tell you that because you got different answers, the limit does not exist. Now for this function, 3x plus 4y minus 2, we want to know the limit as xy goes to 1 comma negative 3. This is a continuous function, and we know about continuous functions from Calc 1. Continuous functions are functions that we can just plug into to figure out limits. And we know when a function is continuous when it doesn't involve any function that is itself discontinuous. And things have discontinuities when we divide by 0, when we try to take the square root of a negative number, when we try to do something that's undefined, that's when my function would stop being continuous. So in this case, 3x plus 4y minus 2, that's just a polynomial. It happens to involve two variables, but it's still a polynomial. And so we can just plug in here. So the limit as xy goes to 1 comma negative 3 of 3x plus 4y minus 2 is just what we get when we plug x equals 1, because the 1 goes in for the x, and the negative 3 goes in for the y. So 3 times negative 1 plus 4 times negative 3 minus 2. That's going to be 3 minus 12 minus 2. That's negative 11. Now for this function, if we try to plug in 2 comma 2, what we're going to see is that on the bottom of this fraction we get a 0. xy would be 2 times 2, which is 4, and then 2x would be 2 times 2, which is 4. 4 minus 4 is 0. We're dividing by 0. But if we plug 2 comma 2 into the top of this fraction, y is 2, so 2 squared minus 4, that's also 0. And whenever we see a 0 over 0 situation, there's a chance that the limit might actually exist. The function won't be continuous there because it won't be defined, but the limit might still exist. So what we could do is approach this problem by trying different paths. And if we did that, we would actually see that all of those paths give us the same value. And that's not convincing, though, because we might just be being lucky and happen to be picking the paths to give us the same answers. So if we really are convinced that this limit exists, we're going to have to do some analysis. And so what you have to notice here is that when we have a 0 over 0, if you want to try to actually evaluate the limit, what you'd like to try to do is try to find a common factor in the top and the bottom of this function. So on the top, we can factor y squared minus 4 as y plus 2 times y minus 2. And on the bottom, we can factor out an x, and so we get x times y minus 2. And we can divide out the common factors of y minus 2. That gets us the limit as xy goes to 2 comma 2 of y plus 2 divided by x. Now it's continuous because when we plug in x equals 2, we're not dividing by 0. So we just get 2 plus 2 on the top, divided by 2 on the bottom. That works out to be